So now that we have an understanding of the Arduino and its digital and analog pins, we have an understanding of how to hook up a simple circuit and run some code. We're starting to make that transition from block-based coding to text-based coding or written language. And we have now the concept of the breadboard under our belt in terms of how we can build this circuit in real life. We are going to move on to understanding functions to a deeper level. So if I was to, let's say, let's go ahead and copy this light bulb and put it in over here, and we'll hook it up to pin 10 and hook that up here, and we'll just keep hooking things up similar to the last example. So there we go, and I'll change that to black. If I was to do this, I would have to then go into my code and I'd have to create another output. So I'd have to go into output, and I can see that this is on pin 10, so I'd have to change the 11 to a 10. So remember that variable has to actually change to the actual number on the board. And if I wanted to turn it on, I'd have to copy all of this coding in and hit enter, and then go ahead and change the 11s to 10s. And you can imagine that this is going to get pretty tedious. And for the most part, the only thing that's changing is this number here, the pin mode. So there has to be an easier way to do this. Could you imagine doing this for like 50 or 100 LEDs? How time consuming that would be? All that copying, pasting, and even if you had enough pins to do it, it would be very monotonous. And that's where functions come in. A function is a piece of reusable code that does something, and you can pass in variables to alter the state of the function. And that's what we're going to look at here right now. So after line 30 on mine, you may have a different number. That's okay. These line numbers, like we've said in class, are just for visual reference, for your reference when talking to people. You may not have these last 4 lines of code. And if not, that's okay, because we're going to get rid of a lot of this here in a second. So at the end of our code, we're going to space down, and we're going to declare a new function. So what does it mean to declare a new function? Well, we're going to start with the keyword void, because our function is going to do something, but it's not going to return any information for something else. So we're just going to use the keyword void. And we want to light the LED. So let's call the function light LED, and we're going to pass in an argument here in a second. So we'll just start with the brackets, and then we'll use curly braces and a curly brace close. So what I've done here is the very basics of a function. I've given it a keyword to declare that it's not going to return any information. I've given the function a name. You can choose to name this whatever you want, but please be informative in the choices of words you use. Sometimes you'll try to use a word and it'll come back as an error. And that's because it's kept by the board. Maybe someone's already used it when they built this board or built the documentation for the board. So I'm going to use light LED because that's what I want to do. I'm going to then close the function, or oops, sorry, I moved something there by mistake. I'm going to then use 2 normal brackets to show where I want to put the arguments. And I'm going to use a curly brace to open and a curly brace to close. By now you may have noticed that these things always come in pairs. Open, close, open, close. One opens to the right, one closes to the left. And that's the same with the curly braces as it is with the brackets. So they always have to be in pairs. So in this function, I'm going to gather my code that currently turns on a light, and I'm just going to copy it and paste it in, because I know this code already works. I know that these 4 lines are responsible for turning a light on and off with a 1-second delay between those functions. So what I need to do here is figure out how do I change this 10 with the pin that's being called in the different lines. So I'm referring to the 13s, the 12s, the 11s, and the 10s. So what I can do is declare a variable of type integer within the function's argument brackets. So you can see that when I typed int, it turned a different color. That tells me that the compiler is recognizing it as a data type. And I need to give a keyword here, and I'm just going to use the word pin. This is a function variable that's called local scope, so it's only going to pass into the function itself. And wherever I want the variable to change, I'm going to type the word pin. So you can see I'm typing over the 10s with the keyword pin, and what's going to happen here is pretty much a find and replace, very similar to what you do in a Word document when you find and replace. So I'm going to delete all of this code. We're going to just get rid of it. And we're going to do what's called a function call. We're going to call the function light LED, and you have to be very specific in the way you type this. It has to match capitalization and lowercase exactly. And I'm going to pass it in the variable 13 because the function, when I look at the function declaration, is expecting a single variable called pin of type integer. And we know from math class that an integer is a whole number. Okay, so I'm going to pass in the value of 13. So what's going to happen is this void light LED int pin is going to actually be referred to as 13, and these pins are going to be 13 and 13 as well. So let's just see what that actually does by hitting start simulation, and we'll see that LED 13 turns on. That's good because that means our variable of 13 is getting passed into the function's argument, and then the function's argument is getting passed into the statements wherever we see the word pin. So if I wanted to call all of these LEDs in sequence, I would just do 4 function calls in a row. So I might do something like this, copy and paste the function call light LED, and then go in and change the variable that I'm passing. 13, 12, 11, and 10. Oops, sorry, and 10. And you'll notice that I made a mistake there. I got rid of some brackets and I got rid of my semicolon. So I should go back and fix that right now. So there's my bracket semicolon, and I'll fix these ones as well. Don't know what happened there. I may have hit the insert key on my keyboard. It's looking like that's what I did. So we'll get rid of those. There we go. All right. So what's going to happen here is the setup will run. It'll declare these pins as outputs, and then void loop will run this function over and over again. 13, 12, 11, and 10 as the variables being passed forward. And pretty much what's going to happen is it's going to enter the void loop. It's going to call this function. And just like you look up words in a dictionary, it's going to go search out this keyword light LED. So here's our dictionary entry if you want to think of it that way. And it's going to pass in the value 13. It's going to do this work. It's going to close off the work or end the work and return back up to the semicolon where it left off. Then it'll turn on light 12. It'll come down here, do this function, come back up, run function 11, or sorry, light LED 11 on line 13 there. It'll run this code, and it'll just keep following this process. And then it'll eventually get to the end of the loop and return back to the top. So let's hit start simulation, see what it does. And we can see light 13, 12, 11, and 10 cycle on and off in sequence. So we've just created a reusable piece of code referred to as a function that can then be used for multiple components of the same type just by changing the variable that we pass in. So go ahead, give this a try. You're going to be doing this in real life too on the circuit, and this will be one of the first times you're introduced to a function, but it will definitely not be the last.